Alright, this is the similar triangles video. Alright, similar polygons. Polygons can be triangles, quadrilaterals, whatever. We'll focus mostly on triangles, but similar polygons are polygons with the same shape. So two triangles, but two triangles that look exactly the same, but different size, which means one's bigger than the other, but they look exactly the same otherwise. Okay, polygons are similar if, not just that they have to look alike, but all corresponding angles are congruent. That has to be true. And the ratios of the corresponding sides are equal. Okay, so all corresponding angles are congruent and the ratios of the corresponding sides have to be equal. Okay, and we'll talk about what ratios are in a minute. Okay, corresponding, remember, means in the same position. Okay, so for example, if I had two right triangles, one big and one small, let's pretend that those are exactly the same shape. Corresponding angles would have to be congruent. So these top angles would have to be congruent. The right angles, of course, would be congruent. And then these bottom angles would have to be congruent. Okay, and then the sides would have to have a corresponding ratios would be equal. So if this side is 4 and this side is 2, that means the ratio would be 4 to 2. That reduces, those are both divisible by 2, that would reduce to 2 to 1. So that means every side has to have a 2 to 1 ratio. So if this side is 6, this side would have to be half of it. It would have to be 3, which would reduce to a 2 to 1 ratio. If this side is 2, then this side would have to be 1. Every single one of those would reduce to a 2 to 1 ratio. This ratio is called the scale factor. Okay, ratios are written with these little colons. Okay, that means one triangle is twice as big as the other triangle. Okay, for a 2 to 1 ratio. Also, if polygons are similar, then their perimeter are also proportional. So the perimeter of both of these triangles would still have a 2 to 1 ratio. Alright, so this example says, what is the scale factor, which is the ratio of ABC to DEF? So triangle ABC is the small triangle. Okay, DEF is the big triangle. Okay, if we're trying to go from ABC to DEF, we're going small to big. Okay, so it would be 8, this side, to 12, those sides match up, and then 10, we could use 10 to 15, and then 14 to 21. Now, all three of these ratios should reduce to the same thing. So 8 and 12 both divide by 4. Okay, so 8 divided by 4 would be 2. 12 divided by 4 would be 3. So all these other ratios better reduce to 2, 3. Okay, 10 and 15 both divide by 5. So 10 divided by 5 would be 2, 15 divided by 5 would be 3. So that's the scale factor. These should all work. 14 and 21 both divide by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. So the scale factor is, or the ratio is 2 to 3. Okay, what is the scale factor of DEF to ABC? So instead of going small to big, now we're going big to small. So instead of going 8 to 12, we're now going to turn around and go backwards and go 12 to 8. So the scale factor here would be the same. It would just be big to small. The big triangle better have the big number. The small triangle better have the smaller number. All right, and then what's the ratio of the perimeter? So let's do the small triangle. 8 plus 10 plus 14 is 32. And the big triangle is 12 plus 15 plus 21 is 48. So we're doing DEF to ABC, so that's big triangle to small triangle. So 48 to 32. Reduce this. These both divide by 8. So let's divide them by 8. 48 divided by 8 is 6. 32 divided by 8 is 4. Well, those both still reduce, so apparently I could have used something besides 8. These both reduce by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. And the ratio is 3 to 2, which it should have been, because from the first box it said that the ratio for the triangle and the ratio for the perimeter should be the same. All right, a valid similarity statement must match corresponding angles and sides. Write a similarity statement for the triangles above. So whatever you name the first triangle, so let's say ABC, then the second triangle better match up. So angle A, since it was first, better match up with the first angle that you write here, which is angle D. Angle B, which has 2 arcs in it, better match up with the next letter that I write. The other, in the big triangle, the one with 2 marks, is angle E. Okay, and angle C has 3 marks, and angle F has 3 marks. So they're written in order. Angle A is congruent to angle D, B is congruent to E, and C is congruent to F. They should be written in correct order, okay, and that'll tell you which angles go together. It also tells you which sides go together, okay. AB should be the same proportion as DE. BC should go with EF, and AC should go with AF. So they're written in order. All right, it says list all congruent angles and write a proportion that relates to the side. So we're going to go through and see which angles are congruent. Okay, so angle J is not actually congruent to N. This second triangle actually needs to be rotated over to where P and N would be on the bottom. If you look at it, you can see that those aren't tilted the same way. So angle J is congruent to angle P, okay, not N. You got to be careful about that. Okay, K, which is the smallest angle, it looks like, would be with M. Angle K is congruent to angle M. Okay, and then L would be with N. Angle L congruent to angle N. Okay, sometimes this is hard to see when the shapes start shifting and rotating. Okay. All right, for the sides, okay, so this side here, which would be JK, I'm going to write a proportion. A proportion is a fraction. Okay, I'm going to write all my fractions small on top, small triangle sides on top, because that's the first triangle drawn, and then big triangle on bottom. Okay, so JK would go on a fraction with MN. If you look, M has 2 arcs, K has 2 arcs, P has 1 arc, and J has 1 arc, so those sides go together. So I'm going to do MP. Alright. Then I'm going to do KL. So let's do KL. And then that should go with MN. Okay, sometimes it's kind of hard to see what sides go together. Okay, but you got to look at your picture real carefully. Okay, and then we'll do JL, which is the bottom of the small triangle, and NP. Okay, these proportions are ratios, they're just written as fractions. Okay, proportion means to write it as a fraction, ratio means to write it with the little colon. Alright, same thing, we want to write all the angles that are congruent. Okay, so we have angle X in the big triangle, this is the big triangle, the whole thing, and then the little triangle would be the one sitting inside of it. Okay, so angle X would be congruent to angle R. Okay, those are the same size angles. One's just in the big red triangle, one's in the little blue triangle. Okay, Z would be congruent to S. Angle Z is congruent to angle S. And then this seems pretty obvious, but it's true. Angle Y is congruent to itself. Sometimes in pictures, triangles will be overlapping. They'll be laying on top of each other, so they'll share an angle, and that angle is congruent to itself. So those are my 3 congruent angles. Okay, sets of congruent angles. And then your sides. Okay, when the triangles are laying on top of each other, in my opinion, it's kind of easier to see. So side X, Y in the big triangle, this whole side here in the big triangle would go with RY in the smaller triangle. Okay, then on this side over here, okay, ZY in the big triangle would go with SY in the smaller triangle. Okay, and then the bottom of the triangle they share. They're exactly the same because they're, oh no, they don't. Sorry. XZ in the big triangle, and then RS in the little triangle. Those are obviously not the same. Okay. Alright. That's all it asks us to do. Find the equal angles and make the ratios for the triangles. Okay, if you notice, I put the big on top of all the proportions and I put the small on the bottom. Okay, you need to keep track and make sure you're putting them on the same spots. Big should always be on top and small on bottom, or small on top, big on bottom, but you have to do it the same way on each fraction. Alright, same thing, except this side this time we don't have a triangle, we have a quadrilateral, but it's the same concept. Okay, angle J is going to be congruent to angle Q. Again, these would have to be rotated, where this would actually be the bottom. Okay, I feel like it's relatively clear to see. Okay, those will both be the bottoms. This would be the top, the little bitty side, and then that would be the top. So this small one could be rotated to match. Okay. Angle K would be congruent to angle R. Angle L would be congruent to angle S. And angle M would be congruent to angle P. Okay, again, the sides, the quadrilaterals are rotated, and that's okay. Alright, and then do sides. I'm going to start with the easiest side that's visually easiest to see. I'm going to start with these small sides, so KL would go with SR, and to me that's the easiest one to see. Okay, and of course I put big on top and little, small on bottom. So you have to do that every time. Big on top, small on bottom. Okay, then I'm going to do, just work my way around. Okay, so then LM would go with SP. Okay, work my way around. Then that would be this bottom here, JM, big on top, and then PQ, the small triangle, and then lastly JK would go with QR. Okay, start with the side that's most obviously matches up and then just work your way around the shape. I find is the easiest way to not get yourself confused. Alright, these say if the figures below are similar with a scale factor of 2 to 3, find the value of x. So I like to write these as proportion. I'm going to put the small shape first because that's what's written first in the picture, and then the big shape second, or on the bottom. So the small shape is 42, the big shape is x, that's what we're missing, equals, and then the small shape is 2 and the big shape is 3. So you can write your scale factor as a ratio, 2 to 3, or a fraction, 2/3, whichever one they're asking you to do. In this case, when you're solving for a missing side, it's easier to write it as a proportion or a fraction. And then you solve using algebra. Just solve the equation. Okay? If you're trying to solve this equation, get rid of the denominator. You can always get rid of a denominator by multiplying. So 2 times x would be 2x. And then multiply by 3 over here. 42 times 3 would be 126. So you can get rid of both denominators by multiplying them to the other side and then keep solving. I'm trying to solve for x, so I'll divide by 2. 126 divide by 2. X would be 63. So you're going to set up your proportions or your fractions and then solve. Same thing here. Okay, I'm going to go big to small because the big triangle's first. So x over 28. And then when I go to use my ratio, I got to put the big one on top and the small number on bottom. And then solve. I can always get rid of a denominator by by multiplying. Okay? So 6 times 28 is 168. And then 5 times x is 5x. Okay? And then a one-step equation, just divide from here. Divide by 5. And this one didn't work out evenly, and that's okay. 33.6. Since all of these are dealing with fractions, proportions, some of them won't come out as whole numbers. Alright, again, find the value of x. This one didn't give us a scale factor, it didn't give us a ratio, but it gave us two sides of each triangle. So, again, set up your fractions, big, small, or small, big. Okay, so I'm going to go with x over here on top. And then the small side that goes with that, if I rotated this triangle this way, would actually be 20. Equals 28 over 25. Okay, you can get rid of a denominator by multiplying. So I'm going to multiply 20 over here. 28 times 20 is 560, and then 25 times x is just 25x. So I got rid of both denominators by multiplying and then divide by 25. So x would be 560 divided by 25 is 22.4. Again, because we're dealing with fractions on all these problems, we're setting up fractions, you're not always going to get a whole number, okay? All right, we're going to focus mostly on triangles, but again, you can use this for any similar shape, okay, any polygon. So again, I'm going to set up big to small because my big shapes first, okay? So let's do 75 on top, and then that would be, go with 40, okay? If I rotated this big shape, okay, then 75 would actually end up on top. Okay, it's the smaller side. Okay, and then X is in the big shape, and that would go with 32. Okay, and then you can always get rid of a denominator by multiplying. So I'm going to multiply 40 over here and get 40x, multiply 32 with 75, which is pretty big, but you're going to get 2,400. And then divide by 40. One-step equation from there. So x would be 2,400 divided by 40 actually does divide evenly, which is 60. So again, these are not always going to divide evenly. Sometimes they will, that's the dream, but they don't always. Okay, when you're dealing with fractions, you don't always get whole numbers, so keep that in mind.